Here are the notes for section 2.4. We're going to be looking at completing the square. Okay, so we're going to be solving quadratic equations by simplifying square roots and by completing the square. So looking a lot at just solving quadratic equations. Sometimes we don't have expressions that can be easily factored, which is why we're going to need to simplify some square roots in order to solve these equations. Okay, so when we're solving square roots, here are some properties. We have explanation written out in words, numbers, and algebra. So basically, if you're solving x squared equals a number, we take the square root of both sides. Be sure to consider both the positive and negative square roots, because remember, when you square a positive number, you get a positive number. If you square a negative number, you still get a positive number. So we have to consider both. That's why we have the plus or minus in front. All right, and as we see here, that is read plus or minus the square root of a. All right, let's do a few examples here, simplifying square roots. All right, let's just do a nice easy equation. X squared equals 36. All right, so following the steps, we do the square root of both sides. Keeping in mind the plus or minus. The square root of x squared is just x. The square root of 36 is 6. So there's our answer. X equals plus or minus the square root of 6. Let's call that number 1. All right, let's do a square root that isn't perfect. Let's say x squared equals 12. We're still going to start out the same way, take the square root of both sides. So we get x equals plus or minus the square root of 12. And what we want to do with 12 is break it into perfect squares. Okay, so remember our perfect squares. We can make a little list. Perfect squares were 1, 4, 9, 16, 25, 36, and so on. Okay, so the perfect square that goes into 12 is 4. So this is plus or minus the square root of 4 times the square root of 3. Okay, so we're just breaking the 12 into its factors. The square root of 4 is 2. The square root of 3 is not perfect, so it stays under the house. And there's our answer. All right, number 3, let's say we have x squared equals, let's say 27. Start off, square root both sides. X equals plus or minus the square root of 27. We look and see which of our perfect squares goes into 27. And it is 9. 27 is 9 times 3. So x equals plus or minus the square root of 9 is 3, and then the square root of 3 is not perfect, so it stays in the house. Okay, number 4, let's look at x squared equals 48. Start off, take the square root of both sides. And we want to look and see which perfect square goes into 48, and it is 16. 48 is 16 times 3. So x equals plus or minus, the square root of 16 is 4. Square root of 3 is not a perfect square, so we have to leave it just like that. Okay, number 5. Let's look at x squared equals 125. Alright, so we look and see which perfect square goes into 125, and it is 25. It is 25 times 5. So when we simplify this, plus or minus, the square root of 25 is 5, and the square root of 5, not perfect, so it stays in there. Alright, so there's a little review on simplifying square roots. So now let's move on to an equation, a little more complicated equation, using our square root property. First thing that we want to notice from the equation is that there's only one term with an x. Alright, so one term with an x, that is our hint, our clue that we're going to use square roots for this. So what we want to do is get the x by itself, and we do that by subtracting 11 from both sides. Next step, we divide by 4. Alright, now this is, well, after these two steps, it's just like the example we did on the previous page. So we square root both sides, and then simplify the 12. And that would be our answer. X equals plus or minus 2 times the square root of 3. If we wanted to check that answer in our calculator, we had 4x squared plus 11 as our original equation. So we put this 2 square root 3 in place of the x, and when we put it in the calculator properly, we should get the correct answer that it was equal to 59. Okay, another example here. Okay, so notice this is different than the first example because we have more than one term with the x. So what we should notice is that x squared plus 12x plus 36 is one of our special trinomials, okay, from section 2.3. X squared plus 12x plus 36 is actually x plus 6 squared. Okay, it's going to be important for us to recognize those special factors. Once we get it to this point, we have isolated the x, so we can go ahead and square root both sides, keeping in mind the plus or minus with the square root of 28. We subtract 6 from both sides to get the x by itself. And our last step is to simplify the 28. So we have to think of what perfect squares go into 28. And it is just 4. It's 4 times 7. So our final answer is negative 6 plus or minus 2 square root 7. Okay, very similar example. We have x squared plus 8x plus 16, and we should notice that this is one of our perfect square trinomials. It is x plus 4 squared, and from here we take the same steps. So we're going to square root both sides, keeping in mind the plus or minus. Then we subtract 4. And our last step here is to simplify the square root, and we should notice the square root of 49 is a perfect square. This is equal to 7. So our answer, negative 11 and 3, which we get because we did negative 4 plus 7 and negative 4 minus 7. That's how we came up with our two answers. Okay, negative 4 plus or minus 7. We do the plus and we do the minus, and we get both our answers. Alright, so in the previous examples we had perfect squares. However, we're not always going to be given perfect squares. So what we can do is rewrite equations as perfect squares And this can be represented using algebra tiles, which you may have used in Algebra 1. So this represents a perfect square trinomial. We have x squared, and then each side is x squared plus 1. All right, so if you follow along here, it's x squared plus 1. And then if we look at the completing of the square, it's x squared plus 2x plus 1. That's how we look at the trinomial. All right, so if we want to complete the square, all right, we have x squared plus bx, whatever that number b is. If that cannot be simplified, we need to make it as a perfect square. And in order to do that, we take half of b, so it's b divided by 2, and square it. And we add that to our expression. Okay, so for example, we have x squared plus 6x, and we need to complete the square. So we take half of 6, square it, and we get 9. Okay, and now we have a perfect square, x plus 3 squared. Okay, so we look, half of 6 is 3, 3 squared is 9. We've completed the square. Okay, so whatever that b term is, we take half of it and square it. And that completes the square. Let's look at this again with our algebra tiles. So let's say we just have x squared plus 6x. Okay, here's our x squared, plus we have 1, 2, 3, 4, 5, 6 x's. If we want to complete the square, we have to look and see we have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces that we can fill here to complete the square. And we get those 9 by doing half of 6 and squaring it. Okay, so just the example that we had on the previous page, except visualizing it with the algebra tiles. Okay, the algebra tiles, it's not something that's a necessary step for you. It's just sometimes a visual representation of actually completing the square is helpful in understanding what we're doing. Okay, so this is just a tool to help you understand. Okay, so let's look at an example where we have to complete the square. We're given x squared minus 14x, and we need to make this a complete square. So what we do first is take half of negative 14. Half of negative 14 is negative 7. And when we square that, we get 49. Remember that when you square a number, whether it's positive or negative, your answer will always be positive. Okay, so when we add 49 to our expression, we've now completed the square and can factor this perfectly. If we want to check our answer, we can multiply out the binomial, and we'll get x squared minus 14x plus 49. Okay, remember your FOIL: first, outer, inner, last. Okay, so let's try this again. We have x squared plus 9x, and we want to complete the square. All right, now this one's a little bit different because taking half of 9 leaves us with a fraction because 9 is not even. That's fine. We have 9 over 2 squared. We can just leave it as 81 over 4. So we add 81 over 4 to our expression. It is now a perfect square, and we can factor this perfectly. We don't have to worry about what we're going to put in here when we factor, because it's always what we had for half of b. Okay, these two spots are always the same. All right, if we wanted to check that, we would multiply it out again, dealing with some fractions here, so it's a little bit more of a pain to check. Okay, but when we FOIL, we should get our trinomial. Okay, so let's look at one more. Completing the square here for this given binomial. All right, so our first step, half of negative 4 is negative 2. When we square it, we get 4. We add it to our expression, completing the square, which allows us to factor perfectly. And then, of course, we can check. Here are the steps for solving quadratic equations by completing the square. Alright, so now we're not just dealing with expressions, we're dealing with equations. Given the equation, we need to group all the terms on one side, all the variable terms on one side, and all of the constants, so just the numbers, on the other side. Now this is an important step number 2. We need to make sure that the a, the first term, is 1. So whichever number is with the x squared, we want to make sure that is 1. And we'll do an example of that coming up. Then after that, we're going to take the steps that we had done in the previous examples. Take half of b, square it, factor it perfectly, square root both sides, and solve for the variable. Okay, this would be a good sheet, good page to print out and have as a reference for you. Okay, so let's do an example. We want to solve this by completing the square. Alright, so if we follow our first step, collect the variable terms on one side and the constants on the other, which means this 12x here needs to get subtracted to go over with the x squared. Okay, so now we've completed step 1. Step 2, we want to make sure the term with x squared is 1. Alright, since the x squared doesn't have a number with it, we know that a is 1, so step 2 is done. Step 3, complete the square. So we're going to take half of -12, square it, and add it to both sides. Okay, remember, anytime you're dealing with an equation, whatever you do on one side, you have to do on the other side. So when we complete the square, we need to add the term not only to the left side, but also the right side. Alright, so we're going to take half of -12 and square it. Half of -12 we know is -6. Squared is 36, so we're just simplifying our math here. So now on the left side, we now have a perfect square trinomial. So we can factor this completely to x minus 6 squared and simplify the numbers on the right hand side. We get 16. Now we square root both sides, keeping in mind your plus or minus. Square root of 16 is 4, so we're going to add 6 to both sides. Alright, keeping in mind that we have +4 and -4. So +4 gives us 10 when we add 6. -4 gives us 2 when we add 6. And here's the two answers for our quadratic equation. Alright, so here's that problem where a is not equal to 1. Okay, so we're going to go through our steps again. Step 1, collect the variable terms on one side, constants on the other. Looks like that's all set for us. The x's are on one side, numbers are on the other. Then we need to make sure that the coefficient of a is 1. Okay, and it is not. So what we do, whatever it is, we divide everything by that number. Alright, and in this case, works out very nicely because each of the terms divides by 3. So 24 over 3 goes in, changes to 8, 27 changes to 9. Okay, so just divide everything by 3. Step 3, complete the square. Okay, so we're going to take half of -8 and square it. And make sure we add it to both sides. Okay, so half of 8 is 4, squared is 16. So we add 16 to both sides. So now we can factor this completely. Let's see, x minus 4 squared equals 25. Square root both sides. plus or minus, the square root of 25 is 5. So now we have x minus 4 equals 5, x minus 4 equals negative 5, x equals 9, or x equals negative 1. And now we're done.